Why do satellites need collision avoidance maneuvers? Have you ever wondered how satellites avoid crashing into each other in the vastness of space? The answer lies in collision avoidance maneuvers. These maneuvers are essential for keeping satellites safe from potential collisions with other objects in orbit, including other satellites and space debris. The space surrounding Earth is becoming increasingly crowded. There are numerous operational satellites and fragments from defunct spacecraft, all of which contribute to what we call space debris or space junk. This congestion raises the likelihood of accidental collisions, which can damage or even destroy satellites. Such incidents can create even more debris, posing a threat to the sustainability of space operations. So, what exactly are collision avoidance maneuvers? They involve making slight adjustments to a satellite's orbit to prevent a predicted close approach from turning into an actual collision. Operators relying on tracking data to predict when two objects might come dangerously close. They assess the probability of collision and decide whether a maneuver is necessary to reduce that risk to an acceptable level. There are several key reasons why satellites need these maneuvers. First, preventing damage and loss of service is vital. A collision can disable a satellite, disrupting essential services like communications, navigation, and weather monitoring. Second, limiting space debris generation is crucial. When a collision occurs, it produces numerous fragments that can remain in orbit for years or even decades. This increases the risk to other satellites and complicates space traffic management. Third, maintaining mission integrity is important. Even small impacts from debris can degrade a satellite's performance or cause failures. Avoiding collisions protects the mission objectives that satellites are designed to achieve. Lastly, managing increasing orbital traffic is becoming more challenging. With large satellite constellations being deployed, such as those for internet services, the frequency of close approaches is rising. This makes avoidance maneuvers more common and necessary. The process of collision avoidance is complex. Operators must balance the need to reduce collision risk with the desire to minimize fuel use and mission disruption. They use advanced tools to analyze the timing, direction, and magnitude of maneuvers to achieve safe separation while preserving satellite capabilities. However, these maneuvers also come with challenges. After a maneuver, uncertainties in a satellite's exact position can increase. This complicates future collision predictions and sometimes raises the risk of subsequent close approaches. This situation highlights the need for improved space traffic management and tracking accuracy. In essence, satellites need collision avoidance maneuvers to protect themselves and the orbital environment from the growing threat of space debris. These maneuvers are a vital part of satellite operations in today's crowded orbital environment, ensuring the continued safe and sustainable use of space.